If you drop a microphone or a car strikes the microphone while you're listening for a thump. Both single channel and directional acoustic detectors are available. There isn't too much to explain about a single channel acoustic detector. It should have the magnetic pickup ability and have both types of microphones so that you're not locked into a hard surface locate. At times you need the ability to work over soil or some other soft material when using a single channel acoustical instrument. Difficulty finding the thump can pose problems. In most cases, this will be the loudest sound, but there are conditions where the loudest sound may not be heard directly over the fault. With a directional acoustic detector, it is not as important to know where the loudest sound is coming from. Its design is based on the speed of sound and uses two microphones placed over the root of the cable. Regardless of how fast the sound waves are moving, the sound has to hit one microphone before it can hit the second. As soon as one microphone picks up the sound of the thump, it shuts the other one down, so only the first microphone hears the thump. A directional acoustic detector system has a zero center meter, like the one used on the earth gradient fault locator. It is called a logic trip meter. Each side of the meter is tied to one of the microphones. When the first microphone picks up the sound and locks out the second mic, the logic trip meter trips in the direction of the microphone that heard the sound first, indicating the direction of the fault. When you walk past the fault, the trailing microphone hears the sound first because it is now closer to the fault. It locks out the lead microphone and trips the logic trip in the reverse direction. This signal that you have passed the fault. Using the same method used in earth gradient fault locating, you can move the probes back and forth to zero in on the fault. The directional acoustic detector operates very similar to an earth gradient, but there are two major differences. The acoustic uses sound, not gradient currents, in its pickup information. And the logic trip meter must trip in one direction or the other. It cannot produce a null reading. Directional acoustics can help locate a fault in a duct. Place a microphone each side of the duct, then treat it like an earth gradient fault locate. Now let's go outside and locate a primary cable fault. This is the primary enclosure where we will set up for a primary cable fault locate. After we seal off the work area, make sure you have all of the live line tools that you need, including high voltage rubber gloves. First, we isolate the cables we are testing at both ends. In this enclosure, we begin by finding the cable that is not energized and possibly faulted. Using a shotgun stick, we remove the test cap cover on each elbow. We test for current with a high voltage voltmeter. It appears that the cable on the far left is the one we're looking for because the middle cable gives us a meter reading and the first cable did not. We pull the elbow on the suspected cable and make one more test before we ground it. We use another type of voltmeter on a shotgun stick to test for voltage and confirm the fault. We attach the elbow to one end of the meter. Then we remove the protective device from the energized circuit. We attach the shotgun stick to the other end of the meter. And place the second shotgun on the energized circuit. An upscale movement of the meter indicates a fault. Having identified the problem cable, we install the protective cap. And ground this end of the cable. With the cable isolated and grounded, we are ready to set up the thumper. And at every stage in the process, we check everything we've done so far to make sure the work is safe, correct, and complete before moving to the next step. We check to make sure all of the thumper controls are off and the function control is in the ground position. Now we are ready to set up all of the necessary grounding. The thumper operator installs a driven ground rod for the vehicle his thumper is mounted in. Ensure that a solid ground is installed between the case of the thumper and the chassis of the vehicle. After establishing our vehicle ground, the next step is to connect our thumper to the faulted cable. We need to expose the cable conductor by removing the elbow. To remove the elbow, we must first remove the center bushing in the elbow. Now that the bushing has been removed, we can pull the elbow off. With the elbow removed and the conductor exposed, we should install a high-voltage rubber blanket that can be used to seal off the thumper connection to the cable. I do not see a lot of people covering up this connection, but it is a good idea and should be done. Next comes the high-voltage return lead. It is connected to the neutral of the cable that we will be thumping. After the neutral connection has been made, we can connect up the thumper's high-voltage output connection to the faulted conductor. Again, inspect everything closely to make sure a high-voltage test can be made safely. Then cover up all of the connections with the rubber blanket. People and pets are sometimes curious, and this rubber blanket will help provide some protection if a wanderer unnoticed into the area. At this point, we should take a close look at the controls that are on the front panel of our thumper we are using. At the upper right, we have a timer that has been set to trip every 6 seconds. The timer tells the thumper to discharge a pulse into the cable, so our thumper will be thumping every 6 seconds. The meter in the top center is our current meter. This meter has a 3-scale range, depending on where the little 3-position switch is set. The range switch is just below the current meter. It allows the operator to control the amount of current used on a burn. The top left meter is the high voltage meter that tells how much voltage is being stored in the capacitor for a thump. We can adjust the amount of current we use in the burn mode, or we can adjust the voltage output of in the thump mode with the large black knob just below the timer on the left side. Just below the voltmeter, there is a black and red push button switch. These are the high voltage on and the high voltage off switch. The high voltage off switch should never be used until the large black control knob has been reduced to 0. There are 3 lights in a vertical row on the center of the thumper. These lights will tell the operator what mode of operation the thumper is set to. The last control on the front panel we want to talk about is the function control switch. This is the control that will adjust the thumper from a ground position to a burn or to a thump operation. When this switch is used, make sure the red high voltage switch is off. And whenever this switch is changed to any position, it should be set back to the ground position before it's set to the new position. We turn the thumper on and adjust for a low current meter reading in the burn mode. This tells us if we can start our thump. It appears from the meter reading that we can thump this fault. We set the thumper in the thump mode. The current meter jumps up scale, showing us that the capacitor is charging. As the capacitor comes up to voltage we have set, it will draw less current, so we see the current meter starting to reduce. When the timer trips, the thumper dumps its stored energy into the cable, and we have a thump. With the thump established, I'm going to use a directional acoustic detector to locate the fault. I could use 2 probes starting out, but 2 probes take a little more time to use, so until I hear the thump, I will only use 1 probe. I have the headphones adjusted to mono and my second probe installed in a belt loop, so it will be with me when I need it. I have turned up my ballistic impulse sensitivity control to the level where I see the magnetic wave go by every time the thumper fires. If you ever hear a sound and the ballistic impulse meter does not pulse upscale at the same time, it is some background noise you're hearing, not the thump. I listen for the thump with the red probe installed in the ground and the acoustic sensitivity turned up as high as the work area will allow. Each time the thumper fires, it trips the ballistic impulse meter. I move down the route of the cable about 10 feet and listen for the thump. After moving to 5 or 6 listening points, 10 feet at a time, that I can hear the thump, so I turn down the acoustic sensitivity control until I just barely hear the thump at the same time that I see the trip on the ballistic impulse meter. I keep the 2 microphones 20 inches apart or more in soft soil. If I were using ground contact microphones on a hard surface, the 2 microphones should be 30 inches apart. If the 2 microphones get too close together, the electronics may not have time to shut the second microphone down because of the speed of sound. This will give you erratic readings. If the cable fault is under a trailer house, it's sometimes very difficult or impossible for you to hear, and you'll have to get over the exact point of the fault. One method I use is the wagon wheel locate, like we did with the earth gradient locate. When I reach the position where my sensitivity control is below number 5 on the decal dial, I insert the second probe into the ground and activate its operation switch. I set the headphones to stereo and I adjust the logic trip sensitivity control up until the logic trip meter trips. Here the meter is tripping to my right, which means the right probe is picking up the sound of the thump before the left probe senses it. I move about 10 feet down the root of the cable and take another stereo reading. My logic trip meter is telling me the fault is still to my right. This time when I move another 10 feet down the root of the cable, my logic trip meter has reversed direction and is tripping toward my left hand. Just like the earth gradient method, I now move back until my meter reverses again and trips towards the right probe. I leave the left probe alone and move the right probe away from the left probe a few inches at a time. When the meter reverses direction and trips towards the stationary or left probe, I begin to move the right or red probe closer to the other 1 inch at a time. Unlike the earth gradient detector, the logic trip meter cannot produce a null reading when it trips. It always moves either right or left. I have found a spot where 1 inch can produce a meter reversal, so I divide by 2 and mark that spot as our cable fault. To make sure that I have located the fault, I can do a 90-degree walk around just like I did in earth gradient fault locate. When I can place one probe in a stationary spot and move the other probe through the 4 walk-around positions, and the meter is always tripping towards the center probe, it's time to mark the fault and shut the thumper down. When doing a wagon wheel locate, leave one microphone sitting in one spot and move the other microphone back and forth until a movement of 1 or 2 inches will provide a reverse reading. If 1 or 2 inches can produce the reversal, the spoke in the wagon wheel will be very close to being dead center. With this film and our short video on secondary cable fault locating, we've tried to present enough information to get you started. With a little effort on your part, time and experience will allow you to expand your knowledge and fault locating techniques. This concludes our primary cable fault locating film. If you have any questions regarding any of the information presented, let us hear from you.